So I'll get started by showing us exactly what we are going to be up to. Now, we're going to be making a game. It's going to be a very particular game, an ancient and powerful game, one that is so intellectually stimulating that scholars will have thought about it for centuries. The game we'll be making here is tic-tac-toe. And in tic-tac-toe, we will be making an automated version, a version we can play on our computers against another player. And if we have some time, we can make it play against the computer. So knowing what tic-tac-toe is our first most crucial step. We play it on an n-by-n board. Usually it's 3x3, but to make it a little bit more spicy today, we'll make it n-by-n. Then again, you make a row and it wins. So you have, let's say, 3 in a row. If it's a 3x3 board, then you win. Everybody knows this, right? Pretty obvious. If you guys have any questions about tic-tac-toe rules, you're welcome to ask, and these slides will be published as well. Players take their turns to play their plays. You can't put an X where an O was. You can't put an O where an X was. That's that. So now, how do we convert these rules into programming? That's our next important step. So before I spoil it for you guys, does anybody want to guess how potentially we could represent our tic-tac-toe board in terms of code? Just welcome to come on the mic if you want to participate. And it is recorded, yes. It's recording, not on Zoom. So. Yeah, that's right. So you could do a 2D array, a 2D matrix. That's like what multiple people suggested here. And that is a good way to represent the board. Can anybody maybe say, how could we prevent ourselves from putting an X where an O once was? So if, let's say, you place an X, how do you stop somebody from putting the O where the X already is? Yeah, that's a very good observation there, and that's something we can do. And one last question I've got for you guys that's a bit more spicy. It's how do we represent what we put in the array? So what kind of a data type would allow us to represent an X, an O, or an empty spot? True or false, says Ishan. Yeah, okay, you guys are saying bool. But how do we do 3 values, right? So, yeah, we could. But if we just use a bool primitive, we'll only have 2 options. So this is where reference types come in. And that's something we'll see as well in this session, where we can have null. Yes, that's right, null and bool. But to do a null and a bool, we do a capital B boolean. And that's what we'll be seeing as well. So here is the sort of formalized version of how we take it from English to programming, which you guys are welcome to screenshot or take a look at. I'll slide through it quickly because we covered it vocally already. So I'll give you guys a second to look at that. That's what we're going to be implementing today, and that's how we're going to be turning it into code. Now here are the important things to take away from the tutorial. You basically screenshot this. This is the information you guys are going to want to know. There is the few key highlights here that you guys really need to know are that an object is some sort of analogy for something in the real world, and it's represented by a Java class, so a .java file. A field is a variable that exists inside of an object. Something static is something that doesn't depend on which object it is. It's just common to all objects of that type, which we'll see in the code. And a reference type is an object which stores a reference to a value, which means it is allowed to be null. And yeah, I can go back to the previous slide if you'd like to screenshot it. I'll just finish with explaining this one. There is the .equals method and the equals method. We'll see the difference between these two in this session, which is very important in your assignments coming up. We'll check null, and we'll see null pointer exceptions, which are going to be like the most common problem you'll face in your code. And we'll see that order matters when you're calling your methods. Now, we'll have various objects in the game, which we'll get to, but I'll just show you the previous slide in case you want to screenshot that and observe it. They will be uploaded to my courses as well, so no pressure if you don't want to screenshot it. You'll be able to download these later on. All right, hopefully everybody's got it. And I'll move on to the next one. So the architecture of our game, as well we discussed it kind of before, is we have a 2D array, and we're gonna kind of format it like it's a Comp 250 assignment. So we're gonna have a little tester, and I'll actually send out the tester to you guys right now, so you can just have it on your computers and get it ready. And I'll show you how we can get it into our project. And then we'll write some of our methods based on the tester, and then we'll finish it up. We'll have a game object, and the game object will be able to establish our board and get everything set up for us to play. We'll have our symbol, which will be a Boolean, and that's either a X, an O, or a zero, or a null. Then we'll have our game application, which runs the game and asks the players for the inputs. Our game will be responsible for setting up the board, which happens in the constructor, for playing, which is responsible for placing an X or an O, to check if somebody has won, so to check whether there's a row of continuous X's or O's on the board, and to display the board and output it to print it to the screen. All right. So if anybody has any questions about like the theory of what we're going to do, now is your time to ask. All right. Assuming that means no questions for theory, if you do have one, you're welcome to say it, and I'll hear it. I don't know how much latency there is, so if I missed your question, you're welcome to just let me know and I can answer that for you. But for now, I'll transition right back over to our desktop, and we can begin with this. All right, so we shall go into the beginning. I'll get my IntelliJ opened up, and we'll get the project started. We're going to be working with a new project today because this is our first session, and we want to familiarize you guys with actually creating the projects. Later on, we'll have like some half-done code already written, and this is not the case today. Right now it's opening our thing for the Python session, so I'll let it do that, but I'm going to create a new file or a new project right after. And you guys could all do the same if you're trying to follow along. So we'll create a new project. And close that. And we'll say Java 15, and no, nothing selected, and it'll be called tic-tac-toe. And finish that up. Close that, new window. Close that. Okay. So now we've got our empty tic-tac-toe project. So as we saw in our various slides, I'm unable to open this file. You don't need to open the file I sent yet. I'll show you how we deal with that in a second. So now we have to remember, what were we trying to do? Well, we were trying to have an object for the game and an object for the game, the thing that runs the game. But since the thing that runs the game is static, we can put it in the main method. All right. So now in our source folder, we can create our Java class, and our Java class here will be what actually contains our game. So here we can have the game class, and it'll be called tic-tac-toe. And in here, as we said before, we want to have a board, but we want this board to be accessible throughout the whole part of the program. So through the whole scope of the program, we want to be able to access our board from various methods. So where do we put our board? Well, that's actually the anatomy of a class. A class represents a sort of object. So this class right here actually represents our tic-tac-toe board, or like our tic-tac-toe game. So this represents our tic-tac-toe game. And hold on, I'm getting a message right now that says, from somebody who says they can't join because the meeting ID is weird. So let me just deal with that really quickly, and I'll get back to that in a second. So from my Zoom. All right, give me a sec. It looks like I posted a bad link to the tutorial, so yeah. There we go. Sorry about that. Posted a bad link there, so people weren't able to get in. Now, getting back to where we were at, we were writing the class for the tic-tac-toe game, and the class is actually what contains all the stuff pertaining to our game. So this is where all of our game-related functions are going to go. This is where our board is going to be stored, and this is where all of these techniques are going to be used. I'm on IntelliJ because IntelliJ is a bit easier to use. And again, in here, we want to have our board. Our board will be a Boolean double array, which will be called board, and we'll just not initialize it. Now, what does it mean when I do nothing with the Boolean board? Well, that just means that it doesn't have any value. So this is completely empty, right? Now, how do we make something happen in the Boolean board? Well, we type public tic-tac-toe, And what this is going to do is this is how we create our tic-tac-toe board. This is the method that we call to start a new game. And here we're going to say board is equal to a new Boolean double array, and we'll have, how big should our board be? Well, we don't know how big our board would be because we want to be able to play n by n tic-tac-toe. We want to be able to have as many dimensions to our tic-tac-toe game as is possible, right? And for that to be the case, we need to be able to input how big our board is going to be. Here I'll say int size, right? And then we'll do our size as our array sizes. And this is also how you initialize our array to be of the correct size. Let's close that properly. And sorry to you guys who just joined, because the link that was posted was not right. So yeah, our board is now 2D array of these specific sizes, and the session is recorded, guys. The board is going to be a 2D array of these specific sizes. For those of you who are just joining right now, we are creating tic-tac-toe, and we are creating tic-tac-toe in well, Java to make it playable on an n by n grid. So this sets up our board with nothing in it so that people can play. And yes, it is recording, but it's recording on OBS, so you won't see the recording thing on Zoom. All right. Everybody clear on the fact that we have this constructor and it creates our board, and that's what we're going to play our game on, right? Okay, cool. So now, what else do we need? Well, we need our methods to do various things on the game. So let's say we want to play, we want to make a move. We can say public void play, right? Or maybe we can make it public string play because we want to see what the result of our play was. So we can say public string play, and we can say, what do we want to do? Well, we want to be able to play to a certain coordinate, so we can say int x coord, int y coord, and let's say Boolean player. Right, and then we take these three things as the inputs, so we're making a play, and we're going to see if all of these inputs are valid. So can somebody give me one of the conditions which might make it so that we can't play, so that we can't make that move? Can anybody think of a way in which it would be invalid for us to play a move in tic-tac-toe on a board which is of dimension, well, size by size? The input is bigger, and there's something there. All right, Vivian and Jessica, you've got the correct ideas. So we can say if x coord is greater than size. Well, both since we don't know what size, we have to do board.length, because for an array, to get how long the array is, it's the array's length. So if x coord is greater than board.length, or, to do an or, we do these two upper lines. Say y coord is going to be greater than board, and now we can say board at 0.length, because a 2D array is like, it's an array of arrays. So what we're doing is we're saying here, if the size of the array on the x-axis is bigger than the x-coordinate, and if the size of the array on the y-axis is bigger than the x-coordinate, then we have a problem, right? So we can say we can throw new illegal argument exception. Let's say your coordinates are too big, and you are trying to play outside the grid, right? Does that make sense to everybody? That we would want to throw an exception here? And does anybody already know what an exception is? All right, so an exception is something that you can do to make it so that you tell people they can't do anything with this method. Rather than returning nothing or returning, let's say, some string that says there was an error, this will tell the user that this cannot be done. In fact, it'll crash the program unless you do something called a catch. So this will crash our program if it's the wrong size. So why do we need to add 0? Yeah, this is the length of the inner array. So when you guys have a 2D array, so when you have a 2D array, you have an array of arrays. So your arrays look like this. Let's say you have an array which will represent with the squares. A 1D array would look like this. Let's say you have, ABC, 1, 2, 3, whatever. That's a 1D array. A 2D array is kind of like that, except instead you have an array, and then in that array you have multiple of these. So you have multiple of these 1D arrays, and they don't have to all be the same. You can have one of these that's 3 long, one of these that's 2 long, and you just have a list of lists, basically. That's a 2D array is like a list of lists, an array of arrays. That's why we're saying board 0.length. It actually doesn't matter because ours is symmetrical. We don't actually have to, but it's a bit of syntax for you guys to see. So here we're dealing with that one restriction. Now there's another restriction we have to deal with, and that is our restriction on something already being there. So we can say if board at index x coord and y coord is not null, we can say throw new illegal argument exception. Something. Yeah, what's up? Yeah, I know. We haven't seen those in class yet, but I'm just showing you guys them now because this is a good way to use them. Like, this is a good place to see what's going on here. And somebody in the chat just came in, so if somebody else in the chat could fill them in, that would be really appreciated. So something is off. You tried to place an X or an O where there is one. And you didn't miss anything super crucial. We're making tic-tac-toe in Java. Right, so those are our two conditions, like our two big conditions for when you cannot place something. There's already a symbol there, and there is not there. But there's one more restriction for tic-tac-toe. That is the player must play their play only when they are not the person who played last. So here we can track who the last player was by saying boolean past player. And here we can say if past player, and I see you guys question in the comments, I'll get to it in a second. If past player is not null and past player is equals, so past player dot equals to player, we'll also throw an exception saying you can't play twice in a row. You cannot play twice in a row. Now somebody's asking, why is it public tic-tac-toe and not public static tic-tac-toe? And that is an incredibly good question. And in fact, somebody else says, how can we access the variable board if it's not the same block? And those two are extremely related questions. So what does it mean for something to be static? Something static is nothing to do with an object. But our tic-tac-toe is an object. We can have multiple tic-tac-toes. So if we have another class here, which we'll create later, but I'll create it now to explain it to you guys. Let's call it tic-tac-toe app. And this one will have a main method, so I'll just create one really quick. So code generate. Do I have a main? No, it doesn't want me to generate a main. Okay, fine, I'll just generate it myself. Public static void main string args. Right, we'll have a main method in here. Here we can say tic-tac-toe t is equal to new tic-tac-toe, and this starts a new game of tic-tac-toe from the other class, and we have to specify the size, so I'll just say 3. Right, this creates our game. So this will actually go and create the board, and when I say new tic-tac-toe, that calls this public tic-tac-toe method. So what we're creating here is an object. We're not actually creating an app per se. We're here creating the class of all tic-tac-toe games. This is sort of our backend. This is sort of like what does the logic. We're not going to be doing any of our display here. We're not going to be doing any of our game logic here. We're actually instantiating like a tic-tac-toe object. And we'll see more of that as we write. I'm just trying to write like these simple methods to get us started with the programming. And then we will explain the object-oriented stuff in a second once we get back to the constructor. The fields are indeed board and past player. So with our play method, once we've checked everything we need to check, we can say board x coord y coord is equal to our player. And then we can say test win conditions. And we can even return that. And then test win conditions can be a string as well. So private string test win conditions. And we'll do this later because I'll need to do some explaining first. All right. So what exactly is the structure of this entire thing? Well, let's go through it line by line. So public class tic-tac-toe. This declares that this is the class of all possible tic-tac-toe games. This is the blueprint for a game. Does that make sense to everybody? Like, this is our blueprint. Every tic-tac-toe game must have all of these properties. So then we say in our blueprint here, we say each tic-tac-toe game must have one of these fields. So they vary by game, but every game has them. Does that make sense to everybody? Every tic-tac-toe game has a board, and every tic-tac-toe game has a player. Clear for everyone? And they vary by each game. So you can have 2 games of tic-tac-toe that are being played, and they will have different boards and different players, but they will both still have a board and a player. Does that kind of make sense? Okay, so that's why they're not static. Because static means, so static means that every tic-tac-toe game has this exact value. So if I made these static, that would mean that every tic-tac-toe game being played will have the same board and the same last player. Something static could be something like the name of the game. So we can say static string game name is equal to, let's say, Super Tic-Tac Bros Ultimate. Right? That's the name of our game. That's static because every time you play the game, every individual instance of the game that you might play. So you might play, 3 of these games. On your computer, you might have a tournament going where you're doing a gauntlet, and you might have 3 of these games running at the same time. All of them will have the same name, Super Tic-Tac-Toe Bros Ultimate, but they will have different boards and different past players, right? That's the difference between static and non-static. Does that make sense to everyone? All right, so now we know that when we initialize our game, see, when I see public tic-tac-toe in size, this method is actually called when I say tic-tac-toe t is equal to new tic-tac-toe. So when I do this in the main method, when I create this new game, this method is called, and it sets up our specific tic-tac-toe. So in the app, we can refer to this game of tic-tac-toe by t. So we can say t.play, and we can make a play on that game. If we have 2 games going, we can say tic-tac-toe, tic-tac-toe t2 is equal to another new tic-tac-toe. And at the same time, we can have, let's say, a size 5 game. And that means that methods that are not static will apply to either of these games. So on tic-tac-toe t, I can make a play that has absolutely nothing to do with the play that's being done on the second instance. So every method and every field without the word static in it, every single one of them will be individual to which game you're playing. But things that are static will be the same for both games. So I don't even have to specify which one. I can just say tic-tac-toe.game-name, and that I can access that for either one. And we'll see that when we write our main method. I see Ayman has his hand up. What's up? That's absolutely correct. It's relevant to every single instance for the class, and it only needs to have one. There only must be one of them for every class that exists. So again, for every instance of our game, it's called Super Tic-Tac Bros Ultimate. Oh, yeah. Oopsies. Give me a sec. Wait, I'm on mute? No, I shouldn't be. Can you guys hear me still? Okay, cool. Sure. So I was saying again, every instance of the game we have is called Super Tic-Tac Bros Ultimate, but they all have different boards and different players. So now do you guys see that all these methods which are not static, they have to do with the specific instance of the game. So when I write play, play refers to the specific instance of the game that you are playing. So it can be T or T2, right? It calls it on that. And the reason we can refer to board and we can refer to last player is that they are attributes that are relevant to that instance of the game. Within a non-static method, you can access your non-static fields and your static fields because they are relevant to that game. You are modifying the state of the game when you play this. Does that make sense to everybody? You're changing something about your object by calling this method. So by calling play, you're modifying your board, right? you're using a method to modify a non-static object. So by calling the play method, you are using a method to modify a non-static object. So by calling play on t to put, let's say, an x in the middle of the board, I would be modifying the t object. So now the board inside of t has an x in the middle. It's like having two pieces of paper with tic-tac-toe games that you're playing at the same time. You can modify this game by calling play on it. So just as I can write on a piece of paper on two different tic-tac-toe games, and I modify those games, I can modify these games by clicking play on them, right? Does that kind of make sense to people? That's all of these non-static methods are like that. But there are actually methods which are common to every game, right? There are methods which you don't care which game you're playing. These methods will apply to every version of the game. And it's very common to write, for example, helper methods that would be like this. So why don't we start writing some helper methods now? And these helper methods are going to be just like what you might see on a quiz. So first helper method I'm going to write will be a static, let's say Boolean. It'll return who won if somebody won. And it's going to be called horizontal winner. And it's going to take as input a board. So it's going to take an input a 2D array of Booleans. Board. And it's going to say, well, it's going to say look for a horizontal where all the elements are the same. If there is one, return who won. One. Else, return null. Now, this is something you'll almost certainly see on an assignment, and the quiz might have a question with one of these for loops, like the ones you're going to write, and it's going to ask, what does this do? So knowing how to do these will really prepare you. And to get you guys a bit engaged, I'm going to ask you guys to see if you could write this kind of method. It takes as input a 2D array and of Booleans, and if there is a line of Booleans which is all equal, then you return which Boolean it contains. Are we using Boolean because tic-tac-toe only requires two options, true or false? That's exactly true, Christoph. And we're using the capital B Boolean because it can have three possible values. It can be true, false, or null. So our board is full of either. So an array of Boolean with a lowercase b will be full of false by default. All right? An array of capital B Boolean is full of null by default. So here we're using null to represent nothing. So null is nothing. True is X. False is O. Does that make sense to you guys? Like it is null, true, or false, right? Okay, so I'm challenging you guys right now to fill in this method, horizontal winner, with the Boolean board. Now, how am I going to see if you guys give me something legit or something that is not legit? Well, I'm going to send you guys this .java file into the Zoom chat. The difference between lowercase b Boolean and uppercase b Boolean is that it's a reference type. So a Boolean with a lowercase b literally stores in your memory a 1 or a 0. But a capital B Boolean says, to know the value of this 1 or 0, you're going to look into, let's say, the 17th index of the memory. And in the memory, you're going to read either a 1 or a 0. But the capital B Boolean just tells you where to look to find it. And since it's telling you where to look, it can also tell you to look at an empty spot. And when you're looking at an empty spot, it's null. So when the capital B Boolean points to nothing, it's pointing to null, and there's no Boolean there. And then it could also be pointing to true or false, because it is just a reference to a Boolean in the memory. We'll get into that in more detail when we have some time. But right now, asking you guys to write this method. The first person to write the method in the chat will have my appreciation. And then we'll test it using this TikTok test class, which is the exact same as how we do an assignment. So to get the TikTok test class, I'm just going to drag it onto my desktop here so you guys can see it, TikTok test. Yeah. So here I've got TikTok test.java. I'm going to go into my IDE. I'm going to right click on my source folder, open in Explorer. Right, gonna find my TikTok test.java file, which is just right here. Close that. Drag that into my source folder. Now in IntelliJ, I see TikTok test, which can run. And let's just fix up tic-tac-toe really quick. I'll return an empty string so that it can run. And I will write the other methods TikTok test requires, because we don't just check horizontal winners. We also want to be able to do, let's say, diagonal winners and vertical winners. So let's just put those in here. Create method, the public static boolean, right? And we'll put these at the bottom where they belong. And once we fill those methods in, we can test it and we can see if our game actually plays. And again, if you guys want to try a solution, I'll give you guys another 4 minutes to come up with a solution to any of these. And then if you come up with something cool, you send in your code over the Zoom chat. I will test your code and we can use it. And if it's a bit of a struggle, I can help you guys out. And while you guys code, I can start with, maybe I can start with the horizontal a little bit and maybe get you guys off to a start. And then maybe you can try the diagonal if it's hard. Or if you've got it, then you've got it. So again, last call for anybody's implementation. If you're working on it right now, let me know, and I might not spoil it fully. Or if you guys just want to see it go, you can see it go. And anybody want to avoid any spoilers? All right, so I'll give you guys a start for it. The first thing we're going to want to do is we're going to want to try every horizontal. So for every row, and a row is going to be an array of booleans. So for every array of boolean row in our board, we can do something with our row. So we can say row, and then we can do something. So do something to the row, right? And this syntax is pretty cool. It's pretty important. We have two different kinds of for loops. So here, this for loop doesn't have an index. And using this indexless for loop, we're able to go through our board and see if there is anything useful in the board. Yeah, the little colon means in. So this is basically saying, so the English version of that is for every list of booleans in the board called row. And now we can do something with the row. So we can say for every list of booleans in the board called row, we can try something. What can we do with it? Well, maybe we can see if they're all equal. So we'll create a lowercase b boolean, and we'll say row all equal, and we'll test it. So I'm gonna guess that they're all gonna be equal, and then I'm gonna try to prove myself wrong. It's a really common pattern in development where you make a guess, for example, guessing that the entire row are all equal to each other, and then to check your guess and to see if it was right. So if you guys can think of a way maybe to think if this guess was correct. So if this guess, well, to check the first thing, we want to know if the first thing in the row is null, there's no use to even keep checking. So we can say if row at index 0 is null, so if there's nothing there, then we can continue checking. Else, well, we know that row all equal equals false. Right, makes sense? Now, if row of 0 is not null, then we know that it's probable that we might have a winner in that row. How can we check that? Well, we can use a for loop that isn't with the colon. We can use a regular for loop. So we can say for int I equals 1, I is less than row.length, I plus plus. So this starts at index 1. Now normally we start at the 0th index, but I'm actually going to be doing something special here. I'm going to be kind of playing with my indices here. I'm going to say if row at I minus 1 dot equals row at I Wait, no, but I want it to not be equal. So if they're not equal, if the thing at the current index is not equal to the thing at the previous index, then I'm going to say row all equal equals false. Yeah, what's up? Line 62, for sure. So this is a special kind of for loop. There's two kinds. There's this kind, which is called an enhanced for loop or a for each loop, and there's this kind, which is just a regular for loop. The difference between them is that this one is a little bit easier to write if you don't care about the index. So here, we don't care which row wins. We just care whether it wins or not. So we use a loop without an index, right? Does that make sense to everybody? We don't want to deal with int I or int j when we just want to iterate through the board and see if any of these rows win. It makes our life a little bit easier to not have to say board at I and then with the second box. It's just so annoying syntax. We could instead just say for every list of Boolean, which we'll call row in the board. It's a shorthand, it's a trick, and it can help us clean up our loop here. Because imagine how ugly this loop would look if we had both an int I and an int j to deal with. Does that kind of make it more clear? Instead of looking for equality, had we used ints to represent them, we could have also summed the values in the column. Sure, Salim, that would be a very valid solution, and you can totally use ints. I'm using Boolean here with a capital B to teach you guys about reference types, among other things. Just to kind of make the lesson a bit more spicy and include some extra content there if I can. But if you want to use ints, that's a completely valid solution as well. One challenge with the ints would be how would you represent a null? You could use a capital I integer, but if you're using the capital I integer, you'd end up having to do a similar thing, because if the value in it is null, well, then, oh no, maybe you could do negatives. You could do negatives and positives. But I could think of ways that, like, if 0 represents x, 1 represents O, sure, you could do a sum, but then if you represent a blank space with a null, you might get a null pointer exception if you try to sum null with something. And if you use something other than null, it could throw off your sum. Can I represent the second if statement? Yeah, I can. And well, here we're checking if the row at index I minus 1, so if the thing in the previous index of the row, we start at 1, right, and we check index 0 against index 1 for the first loop, and we see if it's not equals, then there must be some kind of issue, right? And if it is equals, there is no issue. So, but we're saying if there is no equality between this one and the previous, then we break our row all equal condition and we don't return a winner. But if this never executes, then we do return a winner. We're basically trying to prove there is no winner here. This loop is trying to determine that there is no winner. This loop wants to challenge our assumption that someone won. And it'll say that nobody won if there's no equality. Now, if that loop runs to completion, and indeed everything is still equal, so if row all equal, and that loop is finished and it hasn't proven us wrong, then we can simply say return row at 0. And that returns who won in that row. Does that make sense? What is the point of line 69? Nice. Yeah, what's up? Because here I'm checking row at index I minus 1. And here, yeah. So I starts at 1, but when I do this check, it's actually checking at 0. The reason I do this is so that when we do the for loop, we're checking two things at once. We're playing with I, so that at every iteration of the for loop, we're actually looking at two different things. Does that kind of make sense? What is the point of line 69? This is to make sure that the row is not empty. Because what if we have a row where everything in it is null? Then would anybody win? No, but our condition would say somebody won, right? If we have a row that's all empty, yes, they're all equal. But nobody won. So we have to make sure the row isn't empty. And we only need to check the first one, because even if the first one is 1, it's empty, it's impossible to have a winner. And of course you can ask a question at the end. There will be a question time. But we check if all are null. we don't need to check if all of them are null, because even if one of the horizontals is a null, nobody can win, right? Nobody can win in that horizontal if even one of them is null, because the whole row has to be full of the same thing. So if there's a null in the first one, then it's over. And can we check if all of them are null? Well, here we are actually doing our check if all of them are null. We're checking if row I minus 1 dot equals row 1, so we're just checking. We're going through the whole list and we're checking if they're all equal. And this will include a check for null. Now here is a big red warning. This is like a super important, high importance thing. If we try to call a method on a null, it will cause an exception. All right. Now, that is actually, oh yeah, sorry, I just had to put my my things here. So if we have a null, it'll cause a null pointer exception, and that's a problem. So line 62 just splits the 2D array into the inner array and goes through each inner array and assigns them to a variable row. That's exactly correct, Vivian. This goes through the 2D array and it splits it into a bunch of 1D arrays. Why isn't it? You're completely right. That's a typo, Megan. It should be not equals null. That fixes my code. Thank you for that assumption. Now this should successfully declare a horizontal winner. Let's try it. So return. I'm just going to put a dummy return here for these two and see if our test will pass. So this is how assignments work in Comp 250. You will write a method kind of like this, and then you will run a test. So here I've got a test class, which is I supply. The instructors will always supply you a test. So then you just run your tests, and we'll see what happens. So if I go to my run thing here, it says it failed to declare a winner on the diagonals and on the lines, but it looks like it didn't fail at all on the horizontals. So it looks like a horizontal method is good, right? Because none of these tests failed. But the tests did fail for vertical winners and diagonal winners, obviously, because, well, our diagonal winning does nothing. So this is kind of the idea of how Comp 250 assignments work. We write our methods, and then we test them using these tester methods. Now, before we move on to our diagonals and our verticals, I will screw this one up very quickly, and I will explain to you guys how to fix that. Now, if we run it, we should get a null pointer exception. Oh, and I should also get rid of this else statement. So now if I run this, it should produce a null pointer exception. Right here, see? This scary little null pointer exception. What does this mean? How does this work? Why is it happening? So if you guys ever run into this while you're doing your loops, here is what you do. First, remedy. You click on a breakpoint, you create it, you start with the debugger, like we did in the intro to Java sessions. You start your debugger. If you haven't seen this before, it's okay. You just click a red dot on the side of your line, press the bug icon, and you go through. Then you can go through your code using these buttons, step over, step into, and all that. You can step. You can go through, and you can see what exactly is going on. So right now, our board looks like this. We've got a row of true, true, true. We've got a row, one false and the rest null, and then two false and the rest null. Now we go through, we skip over. Now we're checking. We're checking the last one right now, and we're seeing, does the thing at index 1 equal the thing at index 0? Right now, does it work? Yeah, it works fine. But now we have a problem, because now we're actually checking if the thing at index 1 is equal to the thing at index 2. Now that is null. Is that going to crash us? Not yet, because, well, we haven't had the issue. But now we had our issue. Let's do a replay on that really quick. Go through. I want to get to where our crash happens, right here. Into here. Go. Now our board, we're checking this row. We're checking with two nulls and one not null. We go in here without this if statement that we had before. And here it already warns me null pointer exception. Because if we try to access whatever's at index 0, we know that that's going to be null, right? Everybody can see how index 0 is null. And when we try to do a dot equals on a null, it breaks. But see, it didn't break before when I had a dot equals called on a real object, and then it was compared to a not null. It only called a dot equals on a null. And that's what crashed it. So to prevent this kind of crash, you can use the debugger, and you can see what is null. Here, row I minus 1 is null. So how do I check that? Well, I know that it crashes if the index 0 is null. If the index 0 is not null, there's no crash. So I have to have this if statement in here that says if the index 0 is not null. Does that make sense to everybody why we have that? All right, cool. Now we'll go for the vertical winners. Does anybody want to have a chance at how we can do the vertical winners? Or do you want me to run through it for you guys? If you have any idea for the code for the vertical winner test, you're welcome to send it into the Zoom right now. Or when it's ready. If you're working on it, you can let me know and I can give you a bit of time for it. If statement using inner arrays. Good calls there. Yeah, we can do something very similar. In fact, we can do almost the same thing, except this time we don't have the luxury of this special kind of for loop. This time we're going to have to do it all manually. So we can say for int I equals 0, I is less than board. It's called board. What is this nonsense? Board. I can re-explain the null pointer exception at the end. I'm kind of low on time right now, so you can, if you have any further questions, I can answer those at the end and I can re-explain. But for now, since we are running low on time and I have a few more things to implement, I'm just going to go a little bit fast, okay? And I can re-explain those near the end. I is board.length, I++. Right, so we do a normal for loop to iterate through the board. And this method is designed for a square board. It's going to kind of break if the board is not square. Now Boolean, column all equal, is equal to true, and then we're going to challenge that assumption like before. Here, Aslan says if row 1 is not null, why is index only set to 0? Because we only care if index 0 is null, right? Let's suppose index 0 is null. Then here we're going to say, okay, we're going to start at I equals 1. We're going to say if null dot equals that, it's going to crash. Because if you call a method on null, it crashes. So we care if index 0 is null, right? Everybody understands why index 0 can't be null, because if it is null, we do null.equals and it crashes. But if index 0 is some sort of value, then it won't crash, because then it actually runs the equals method on that object. So if index 0 is not null, it works. But if index 1, say, is null, it will work, because if you say some object which exists is equals to null, well, it's not going to be equals to null, so it's going to enter this, it's going to break, it's going to stop the loop, and it's going to go because it's already proven itself wrong. So any index besides the first can be null, because null can go here. Null cannot go here, but null can go here. So whatever comes after the index 0 can be null, and I can explain that more at the end. All right, so we're assuming the column is all going to be equal, but actually first let's get through the column. So yeah, column assumes going to all be equal. The first of our column, so we'll say Boolean first in call will be board 0 and I. Remember, we're doing verticals, so these are kind of going in the opposite places compared to before. All right. We're going in the opposite order compared to what we're used to. And now we're going to do a really weird for loop. We're going to say for int j equals 1. Equals 1. J is less than board.length. J++, remember we can do nested for loops with I and J. If you did Math 133, you'll remember I and J from your vectors. Similar convention. If board at ji, I is not null, or is not column first, first in column, column all equal is false. All right. So here we're saying if whatever is located in this index of the board is not the same as whatever is the first one, then it doesn't work. And then if at the end they're all equal, we'll return whatever was the first thing in the column. Now there's one issue with this. We want to make sure the first in column is not null. So we'll just say if first in call is not null, or we can just say if first in call is null, column all equal is false. And we'll just do that check right away, and we'll put this at the end. So we'll deal with the null, and we'll say if the first in call was null, we'll get rid of it. And in fact here, everything seems fine, right? Does anybody disagree with my vertical winner? We advance through our arrays, we go through our columns, we put our column all equal flag to see if it's true or false. If it's not equal to if any of these are not equal to the first, then we have our problem, right? It seems to be logical. Except there's one little issue with it, and that is the fact that we're not comparing lowercase b booleans. We're comparing uppercase b booleans. So we have to do a dot equals call here. Again, equals will not work, because when we're comparing the things that can be null, the things with a capital, the equals will compare the memory addresses. It won't compare the value. So if you have two things at different addresses, they can still have the same value. But they would be not equals. So we say if board ij does not equals the first in column, then column all equal is false. But now board ij might be null. So in fact, what we should do is we should say if first in call does not equal to board ij, or board ji, board ji, then column will equal is false. And then we also want to make sure that if first in column is null, we can just return, or not return null, we can just break. Or what can we do? What's a good thing we can continue. That would be a nice move. Continue means we skip the rest of the code and we go to the next iteration of the for loop. So here we say, if first in column is null, we continue, we go to the next index of the for loop. We don't deal with it. And if it's not null, then we do these statements. And yeah, sure. You know what, IntelliJ, I'll take your suggestion. Now, if we run our tests, let's see if we can pass our vertical tests. Okay, so now we've got all our tests passed except diagonal, and that one is actually the easiest. We've got 5 minutes left, so I'm going to try to go really fast, and then I'll be open to all your questions. So the diagonal one is a similar kind of for loop, but we actually only need to use one for loop. So it's the easiest one of them all. So we'll say Boolean first corner is just going to be the 0, 0 index, right? Because we're just checking, we're checking between the corners. So 0, 0, right? Pretty simple, right? Now we'll do another Boolean for whether it's 1 the first diagonal. So we'll do Boolean has 1 first equals true. And now we'll say if first corner is not null. And we can use the regular equals for null because it's not an object. We're just comparing if the memory address is null or will go to null or not. It's a different style of comparison. And now we'll say for int I equals 0, I is less than board.length, I plus plus. And yeah, here we can say if first corner dot equals board at II, because we're doing a diagonal, right? So we want the loop to iterate the same on both axes. So we'll do board at II. We'll say has 1 diagonal, has 1 first, will be false, and we'll break. And if it did win after the for loop, so if has 1 first, we'll return our first corner. Now, that's all good for the first corner. How do we do the second one? Well, let's be lazy. Let's just take all of our code here, copy paste it, except we'll change first corner to be second corner. And we'll do at board.length minus 1, so it's the last one, and board.length minus 1. And we'll say has 1 second. And we'll change all of these to has 1 second. And now, bam. And first corner, of course, should be changed to second corner here. So now we can check our various corners. Let's try a tic-tac test. Missing return statement. Oh, yeah. And if you ever get that error, you just return null at the end of whatever you were doing. And then that can be a quick fix. Right? So now we don't fail any tests and we're ready to proceed. So now we can finally finish our play method, which was up here, where we want our test win conditions. So now we can say, for example, if horizontal winner on board, so if there's a horizontal winner on the board, is not null, then we can say, we'll just call it a Boolean winner. So it's a Boolean winner. And we'll say winner equals the horizontal winner on the board. And then we can do the same thing for all the different kinds of winners. So we'll check every kind of win. We'll say if there's a horizontal winner on the board, if there is a vertical winner on the board, and if there is a diagonal winner. And notice how these methods are italic. That's because these are static. Now remember back to earlier in the tutorial, we talked about static versus non-static. The conditions for winning, those don't vary by game, right? Those conditions for winning are the exact same no matter which game you play, as everybody would understand, right? So these three methods are static. Why do we make them static? Well, we made them static because in our test, we don't want to have to write, tic-tac-toe game t is equal to new tic-tac-toe game. We just want to test our algorithm directly. By making them static, it's super simple because instead of creating an object and doing all this work that we'll have to do soon, we can just do this simple horizontal winner check. And it's as simple as that with the static. So that's why we have these as static methods. Does that all make sense to everybody? Does anybody have any questions about that? And sorry, we are going to go a bit over time today just because of the kerfuffle we had with this link at the start and everything. If you've got to go, then obviously it will be recorded, but I encourage you to remain and see the rest of it. So do you guys see that we're using these static methods to check our winners and how we're going to use this in our play method, right? All right, so now we can say if somebody won, so if winner is not null, we can say, let's say if winner is not null, might not be initialized, so we'll start it off as null. If somebody won using any of the ways, we can say if winner, so that means if winner is true, return X wins, else return O wins. And here we can say if none of these are true, then we can say return nothing. Nobody wins. We just we return an empty string. Now here, our play method will put something on the board, and then it'll check the win conditions, and it'll see if anybody won. And if it won, our play method will say so. Does the structure of our app make sense to everybody? How we can create a tic-tac-toe game. Once we create it, we can make a play. If our play makes it win, it uses these static methods to check if it won. And then from these static methods, it will tell the game, okay, you won or you didn't win. Because the game rules are the same for every instance of the game. It'll say if you won or you didn't win, and that'll be fed back. Does that kind of architecture make sense to everybody, our game? Okay, perfect. So now let's actually write a playable version of our game. I'm going to do it quick just so that we can do everything we need, and this one will be all static. So remember, our game was non-static because we had multiple versions of it. We'll make a static version now. Let's just say public void display, and this will display our game, our game's environment. So we can say public static void display. Let's say static void display, and it will take as input a game. So it'll say tic-tac-toe game, and this will display our game. How do we display our game? Well, we just do a for loop through our board. So remember, each game has its board associated with it. So we can say, for instance, for every row, the same as we did for our horizontal one, we can say for Boolean row inside of our game dot board. So the board of our game, we'll do for Boolean item inside of our row. So for every Boolean in our row, if the Boolean is null, if item is null, we'll print like a dash to show that there's nothing there. I know these graphics are great. If you don't have an RTX 3090, you will not be able to play this. And else it will do a if item. We will display an X, so system out println X. And else we'll do O, right? That's pretty simple for everyone. We traverse through the entire array, and we will put an X or an O if they're there, else we'll put nothing. We'll put a dash. The method's pretty clear to everybody, right? The spicy part is right here. We take a specific game, and we look at the board from that specific game, right? And now here in our main method, we'll be able to do something, right? So let's start asking the user for stuff. So scanner s is equal to new scanner on system.in, and we'll have to import new scanner. Forgot the new, right? And we'll say system.out.println, how big of a board do you want? Oh, before we do that, let's tell people the name of the game. So we'll say system.out.println, welcome to, and then we'll say the name of the game. So we'll say tic-tac-toe.game-name. And so see, before we even create the game, we know that the game is going to be called that because it's static. So this is static, so we can access it. So yeah, this is static, common to all games. So before you start your game, you can still see it. Now, we will see if I try to access the board before I create it, it doesn't work. I can't do tic-tac-toe.chromaticity. I can't do tic-tac-toe.board. It doesn't work because there's no game yet. We haven't started the game. We've just looked at the name of the game. How big of a board do you want? And we can say int board is it going to be equal to, or I guess int size is going to be equal to s.next int. And then we can say tic-tac-toe game is going to be a new tic-tac-toe of that size. So easy peasy, right? Makes sense to everyone. Pretty simple method. Then we can say, we'll just do a two-player game for now, and I'll show you guys how to do a one-player game against a robot maybe tomorrow, or not tomorrow, Friday in the next session when we have some more time, because I want to get to some questions today as well. And then we'll just say, while true, and we'll have a boolean here. We'll say boolean player equals false. And now, of course, we can do a simple loop. We'll say our string player is going to be an O. I guess our string name is going to be O. And our boolean, now we already have a boolean for our player. So now we're going to say if player. So if the player is true, they're going to be an X. So name is equal to X. And if it's false, the name is equal to O. So this maps sort of our strings to our ints. Right? If you guys have questions, you can ask. You don't need to do like the Zoom hand raise. And then we can just simply go, system.out.println it's, and then we'll say our player name. So let's say name, name's turn. Then we'll do a we can do a display of our game. So we can say, we'll show them the board. And now we'll say println x coordinate and int x coord is going to be our scanner dot next int, and then system out println y coordinate, and we'll do int y coord is equal to s dot next int as well. And now we're going to be able to do our play, so we can say game dot play on x coord, y coord, and our player will be our player. Right? Makes sense. And now we can say we'll just do x turn, and we'll also system out println, because remember game.play returns a string, so we'll do a system out println of our game.play, and we will do our game.display after the play is made as well, or display of game. And one last thing we probably want to do is we want to be able to reset it. So if it's 1, let's say when there is a winner, where is this, a winner in the game, we probably want to reset our board. So regardless of who wins, we'll say that the board is equal to a new boolean of board.length and board.length. So we'll reset the board if somebody wins. And bam. But that way we'll never be able to see the winning move, whatever. Well, we can do that if we want. We'll display the game. And we will flip the turn. So we'll do player equals not player, so it'll swap which player is playing. Now if we run this, hopefully it should all work. So how big of a board do you want? Let's just do 3 by 3. We're not printing properly. Why? It's because it's print line. It should be print. Print. Print and print line are different because the print line will create a new line, whereas print will just print off the boolean. And don't worry, guys, we're almost done. Thank you for hanging in there. Went a bit overtime today because of our slightly late start. So print, and then at the end of this row, we will do a print line. Not for each item, but we'll print a line for every row. Now, if we run it, we should have a proper board. So, how big of a board do you want? 3. It's O's turn. X coordinate 0. Let's do 0, 1. Now we've got an O. Now it's X's turn. We can put an X right in the middle. Let's do 1, 1. Now, if I try to put something invalid, like let's say 559 and 33, it's going to say illegal argument exception. It's going to stop the game because your coordinates were too big, and that's something we wrote before. But the game should win. Let's see if we can win. Let's do a 3 by 3 board. O will place just at 0, 0. X will place at 1, 1. X will place, or O will place at 0, 2. X will place at 2, 0. O will place at 0, 1. And now O has a row. O wins, right? So our game works. Our turns don't reset very well right now because our game doesn't reset. So if I go back into tic-tac-toe.java, and here I put in a line that says board is equal to new boolean of board.length and board.length. Now our game resets when you win, and our game is done. So before you guys go, I'm going to drop you off with a couple of takeaways. First off, we've got a document here which covers all of the content from today and has some extra content as well that we didn't get to. That's kind of our summary today. Then I've got our finished project, which you guys can look at the code for, which I'll send you guys the link as well. These 2 links are in the Zoom chat. After I send these links, you're welcome to ask whichever questions you would like, and I'll be happy to take some time to answer them. So your questions can start now. And thank you for sticking around. These links will be on my courses soon, yes. And yeah, question time. Could you please explain... Oh, go ahead. I'll get to the chat question, and then I'll get to you. Thank you, Yuri. Could you please explain the difference between capitalized Boolean and Boolean? Sorry, I missed it. Okay, crucial difference between those 2 things. Let's get to that. And let's also, I kept forgetting to change my topic up here. Sorry to people in recording. Recording will be better next time. So the difference between the capital B Boolean and lowercase b Boolean is visible here. So a reference type, where is that slide? Here. Under reference type, if you look at the Google Docs link, I have more on it. It's an object which is kind of a pointer. It stores something in the memory. So a lowercase b Boolean, what it actually stores on your computer is either true or false. Right there, the actual word Boolean itself maps to true or false, right? Well, the capital B Boolean doesn't map to true or false. The capital B Boolean maps to a place in the memory where we have a true or a false. Why do we have this? Why do we waste so much room to put a pointer to the memory to where we have a true or false? Well, we do that so that we are able to have it as null or have it as a different value. And that is able to benefit us by giving us 3 possible options. Does that make sense, Vivian? The capital B Boolean lets us have null. That's the short of it. And once we go more into objects in future tutorials, you'll see a lot of detail on that. On next week's tutorial, you will understand that perfectly because we will make something similar on our own. Here, I'm just trying to get you guys to help with the syntax. You can't have null with a small boolean. Well, let me show you. So if I have, let's say, a boolean, a lowercase b boolean, and I'll call it sad bool is equal to true, right? That works, no problems. Sad bool is equal to false, no problems. Sad bool is equal to null. Now that's giving me a compile time error. Why is it being a compile time error? Well, that's because it's a primitive type. A bool is a special kind of thing in Java, a regular lowercase boolean. And sorry if I didn't transition the screen there to IntelliJ, did I? No, I missed the transition, sorry. I'll give you guys that again as a replay. So if I create a sad boolean, like a regular boolean, so lowercase boolean, sad bool is equal to true, it works. Not to test win conditions, to true, it works. To false, it works. But to null, it doesn't work, it doesn't compile. That's because sad bool is a special type of variable which can only store a true or a false. It can't store a memory address, and null, you require to be able to store a memory address to store it. So nothing with a lowercase letter can store a null. All right, so Yuri, you had your question. You're welcome to ask away. For test to win conditions, let's find that. Yeah, let me find that for you really quick. So the reason I'm not using if else is because let's say hypothetically there was no horizontal winner. Yeah, if else would carry through and it would work fine. But there's also no difference between what happens if there is no else, because here this will be false. It'll skip over to this. But we can also have multiple winners. So if we don't have an else, and we have a vertical winner as well, it will consider all those wins. It's not really a design choice, or neither is wrong or right. It's more so that I want it to be so that, let's say we're in a really weird case, an impossible case where there's multiple winners on the board, all the winner checks will execute. There's not really a great reason for it. It's just kind of something I liked. So I guess we give priority to diagonal winners. Like if you win vertically, you get higher priority than somebody who wins horizontally. You get higher priority than somebody who wins vertical. But the real answer to your question is we can use if else, or we can use if. It actually makes absolutely no difference for how our game works, because within our game rules, you can't play two at once. You can't have two wins happen at the exact same time. It actually makes no difference in the real world. But in the pure theory land and dreamland, we can say that here it kind of gives some unspoken level of priority to diagonal winner. But that's all bullshit. Really, the answer is it doesn't matter. Sure. And of course, any further questions, anything that was unclear to you guys, I'm here to explain it. Now is your time. On Friday's session, if you missed some of this session, you're welcome to come to Fridays, where I'll be, more well aware of how much time I have and won't go 15 minutes overtime, and we'll probably cover the content a little bit better, just because we had the feedback from you guys about what was clear and what wasn't, and it can go, if you didn't understand this one fully, that one will be probably more understandable for you. And otherwise, hope you guys really enjoyed it. Any more questions? It's your last call right now. Oh, it doesn't matter actually. I can make it public. I can make it non-public. It's because I forgot to type the word public. No reason more grandiose than that. Since see, all of these are in the same package here. There's no package for tic-tac-toe. They're all in the source folder, right? If I had a package, and let's call it game, and then here I had another package called test, right? And I put tic-tac-test into test. Now it's going to say that I can't do it because this one is it's package private. So that is one thing that the non-public is a mistake for. It should have public, because if I move the test to a test package, then I'm not able to access that method. That's the only difference between having it like this and not having it like that. When everything is in the same package, it actually doesn't matter if it's public or not, because nobody cares. Everything is in the same package, so not having public does nothing. You may as well not have it. But if I were to have a separate package, I could not access a non-public method. The reason these have public in front of them is that if you want to follow a convention that we have sometimes, which is to separate your tests and your code, then you want them public so the test can access them. I'm confused why, if winner is true, we'll return X wins. The reason for that, Christoph, is that the X is represented by the true, and the Y is represented by the false. Nobody winning is represented by null. Does that make sense? Nobody wins means that winner is null. True wins means X, false means Y. And this is just to show you guys that we can use a reference type to store 3 values, and it's to show you guys that we can be clever and creative about how we use our variables so that our values are the most efficient possible. You're wasting no memory at all using 1 bit to store your X and O, rather than storing a massive int. Like, an int could be anything between like 2 million something. You don't need 2 million possible values to store an X or an O. So, yeah. I see Fahim's got a mic on. If you've got a question, you're welcome to ask. Yeah. Yeah.
Java doc that you have shared with us. So if you don't mind, I can share my screen.
If you share your screen, I won't be able to capture that on my recording, so I can do it on my Eclipse, and I can show you like that.
Please.
And that hopefully will help you out. So that's to add a test. And again, with our assignments in Comp 250, we always get this kind of test.java file. Like the one I sent to the Zoom chat, we always have a test.java. It's never a case where we don't, basically. And we rely on using these tests to test the methods for our assignments. And again, our assignments are going to be very similar to this, where you'll have one of these methods, like these static methods for the winners, and you have to write this algorithm to do that. And your quiz questions are going to have code that looks almost like this. And they're going to ask you, what does this code do? Why is there a null pointer exception? Your quiz question could look like this. It could say, this code right here without the if is null, why can this have a null pointer exception? That would be an example of a good quiz question. And if you can understand that well, then congratulations, you're hopefully going to do very well on your quizzes. And next time when we have more time, I could include something that looks of the same format as a quiz question. Maybe on Friday I'll include something of the same format as a quiz question to help you guys with that. But here I've got, I'll just open up Eclipse really quick to show you importing our test, because it's very important. And while Eclipse opens, does anybody else have a question?
I have another question.
Oh, sure. What's up?
Like how? Just it's a weird question. I imagine. Like how tough the assignments and quizzes are going to be compared to Quiz Zero. Like Quiz Zero was, I think it was straightforward, like relatively.
Yeah, so, quizzes are going to be what's more challenging in this course than assignments from most people's experience. They are relatively hard. I would say don't underestimate the quizzes. You're gonna see some very particular code. You're gonna have to very well understand what's going on for the quizzes. So these are to help you prepare a lot for them. That's why I'm making sure everything's kind of similar to the quiz, because they kind of get you. The assignments are going to be a little bit easier, not because the content is easier, but because you have all day to do it, and you have, you can write testers and you can share testers with your friends to make sure that your assignment is absolutely perfect before you hand it in. So you have more opportunity to correct yourself. On a quiz, you really have to know.
For quizzes, so sorry for the interruption. For the quizzes, like you will have only 1 hour to do it, right? So that's
yes. You have a time limit on the quizzes, and of course, with an assignment, you have you have the whole internet, you have your IDE, you have every resource available to you. You can work with your friends on debuggers. Like you can't collaborate on the assignment itself, but you can make debuggers together, which can help grade your work and check how good it is. And between all those resources, your assignments should be, if you work efficiently, your assignments shouldn't be too bad, and if you work quickly and you work ahead of time. But your quizzes can cause you a lot of stress, even if you're.
Thank you for that.
You ought to prepare for them. So here in our thing, I don't even know what this project is in my Eclipse. I haven't opened it in a while. But if I want to add something here, I can right-click. I can show in Explorer, show in System Explorer, I suppose. Here, same as IntelliJ. It's very similar. We've got our File Explorer here now. I can take my my file. So I'm going to take it out of my IntelliJ one, just because that's where I put it. I'll take TikTok test. I'll Control-C it. And I'll Control-V it into here. And now if I refresh, I see it right here. And that's all you have to do.
No, but if you go on the one that you did today, if you add the tic tac test over there,
Yeah.
it's possible to show me, please? Oh, okay. So you use IntelliJ, okay.
Yeah, UI is different, but I just showed you adding TikTok test here as well. It's the exact same thing. You right-click on your source folder again. You right-click source folder. You then show in System Explorer.
Oh, it's showing. Okay.
Yeah, and then you see your source folder right here. You drag it into there, and you're all done. Then after that, all you have to do is right-click, refresh, and you see it appear right there for you.
Show in and System Explorer.
Yeah.
And then I can take it. Okay, I see. I got it. I can take it from desktop. Perfect.
Yeah, and you can just drag it right in there, and it should work just fine. You'll be good to go. Yeah, I only showed it in one IDE because it's so similar between the two IDEs.
And where I can drag it?
Yeah, you just drag it in and you're done.
Oh, in the source. Okay, perfect.
Yeah, just drag it into the source folder, and then when you're in Eclipse, you just right click and you refresh because it doesn't automatically refresh. You just right click, click refresh, and it shows up. And then again, in IntelliJ, it's the same. You right click, you open in Explorer.
Yes, I got it. Yeah, I got it. I was able to add it. Yes, got it. Thank you so much.
Okay, for sure. Any last questions, guys?
Thanks, Sasha, for today.
Of course.
Thank you, Sasha.
Thanks. See. Bye.
Alrighty. Any other further questions? All right. See you guys later. Thank you for the great tutorial. Again, Friday session will be same content, but it'll be explained a bit better. And on Friday, we will also make an AI that plays the game against you. We just didn't have time to get to that today. All right. Great stuff, guys. Farewell.